In this question, it's given that consider the following system of equations, these three, for some value of alpha and beta belonging to R. Then which of the following is not correct? Whenever we have to solve three simultaneous equations, there are two methods. One is using Cramer's rule and second is using the concept of augmented matrix. The way of using augmented matrix is usually short than the Cramer's rule. It's clear that the augmented matrix for the given three equations is alpha 2, 1 and 1. 2 alpha, 3, 1 and 1. 3 alpha, 2 and beta. And now using elementary row transformation, I will be converting this matrix into echelon form. That is, I will make these three elements 0 with the help of elementary row transformation. And after that, we will decide. If you don't know the concept of augmented matrix, I will suggest you to see my video of matrices for JEE. First of all, I use the operation R3 changes to alpha R3. That is, I am multiplying this row by alpha, so that when alpha, 2 alpha and 3 alpha will be there, it will become easier for me to make it 0. And hence I get alpha 2, 1 and 1. 2 alpha, 3, 1 and 1. 3 alpha, alpha square, 2 alpha and alpha beta. I can make it 0 by using the operation R3 changes to R3 minus 3R1, or I can make it 0 with the help of this operation also, R3 changes to R3 minus R1 plus R2. I find it slightly better, therefore I am going to use this operation to make it 0. And I get alpha 2, 1, 1, 2 alpha, 3, 1, 1, 0, alpha square minus 5, 2 alpha minus 2, and alpha beta minus 2. And now make this element 0 by using the operation R2 changes to R2 minus 2R1. I will get alpha 2, 1, 1, 0, minus 1, minus 1 and minus 1. 0, alpha square minus 5, 2 alpha minus 2 and alpha beta minus 2. I use the operation R2 changes to minus R2. Alpha 2, 1, 1, 0, 1, 1, 1, 0, alpha square minus 5, 2 alpha minus 2 and alpha beta minus 2. Now I will make this element 0 with the help of this element. That is, I use the operation R3 changes to R3 minus alpha square minus 5 into R2. I will get alpha 2, 1, 1, 0, 1, 1, 1, 0, 0, and here I will be getting 2 alpha minus 2 minus alpha square minus 5. And here I will be getting alpha beta minus 2 minus alpha square minus 5. If you have studied the concept of augmented matrix, then you must be knowing that if this is non-zero, that is 2 alpha minus 2 minus alpha square plus 5 non-zero, then the equation will have unique solution. That is alpha square minus 2 alpha minus 3 not equal to 0. That is alpha is not equal to minus 1 or 3. Hence, if alpha is not minus 1 or 3, then the equations will have unique solution. If alpha is minus 1 or 3, then this will become 0. And after it has become 0, at that time this also becomes 0, then the equation will have infinite number of solutions. And after this has become 0, but this is non-zero, then the equations will have no solution. Now, first case, if alpha is minus 1. If alpha is minus 1, this becomes minus beta minus 2 minus 1 plus 5. This is non-zero, and this means beta is not equal to 2. Hence, if alpha is minus 1, beta is not equal to 2, it has no solution. Hence, information of first choice is correct. And second choice says that it has no solution for alpha equal to minus 1 and for every value of beta. If alpha is minus 1, this becomes 0. And for alpha equal to minus 1, if this becomes 0, it will have infinite number of solutions, and if it is non-zero, it will be having no solution. And this is 0 means beta is equal to 2. Hence, if alpha is minus 1, beta equal to 2, then infinite number of solutions will be there, but it is saying has no solution for alpha equal to minus 1 and for all values of beta. But no, for alpha equal to minus 1, beta equal to 2, there are infinite number of solutions. And because information of second choice is wrong, therefore second choice can be taken as correct choice. Still, for your clarity, I will check the third and fourth also, just for clarity purpose. If alpha is equal to 3, this will become 3 beta minus 2 minus 4. That is, it will become 3 into beta minus 2. And if alpha is 3 and this is non-zero, then no solution. If alpha is 3 and this is also 0, then infinite number of solutions are there. Hence, the information of third choice is correct. And the information of fourth choice is also correct. If alpha is neither minus 1 nor 3, then it will be surely non-zero. And if it is non-zero, unique solution is there. That is, second choice is correct, because the information of second choice is wrong.